Hello friends, once again. Uh, in this video, we are going to learn this deeper section, this schematic diagram. So like pin out on the SIO, if the laptop is not powering on, then which pins we have to check on the SIO. And for that, we are going to use a schematic diagram as well as a board viewer. So here is a diagram. So this is the motherboard number is LAG717. So this is schematic diagrams I am going to open with the Acrobat reader, and this diagram is open, and this page is basically a block diagrams of this particular schematic, and here is a CPU, is the Canon leg, Comet leg, and here is my SIO. Here is SIO, and SIO is on page number 58. SIO number is SMSC MEC 1418. Okay, so we are going to check all the signal on the SIO, and we are opening a board viewer also. So this is a Flex PV. So this is a Flex BV board viewer. So this is a nice board viewer. So we'll open a BRD file. So BRD file or board viewer file is normally extension of BRD or BDV or CAD file. So here I already download this CAD file. Okay, and I click on the open. So now the board viewer will open. Cancel this. Okay, so this is a board viewer. Okay, and this side is the CPU side and this side is the back side. So this is we can say the front side or the top side, or this is the back side. Okay, and here you can see the CPU, and then these graphic chips, the graphics RAM, and here's the memory, and this side is the SIOs there. Okay, so we'll go first to the schematic diagram. Here's the schematic diagram, and we'll see. We'll go on the page number 58. So this is the page number 58. We'll go to the page number 58. I'll type here 58. So this is a schematic diagram. So what we have to see if our laptop is dead, that is very important. So if you have a laptop which is not powering on, then and now if you want to check all the signal on the schematic, so how to check and which are those signal that you have to check, that we are going to learn in this sessions. So first thing, you have to check the supply pin. Okay, the power. So this is the MEC 1416, the location is the UE1, and these are the supply pin. Okay, so which are the supply pins are? So pin number 43, 82, 105, 5, 19, 65, any of this pin you can check the supply pin. Okay, so this supply is coming plus 3 VA, 3 volt, 3 VA means 3 volt, ALW means always, and underscore EC. EC means stand for SIO. SIO normally says EC embedded controller or KBC, then that means the keyboard controller. So we'll come to the board viewer. Okay, so this is a board viewer, and we'll zoom these sections. UE1, so this is our SIO. When I click on here, at then right hand side, all the pin descriptions are given. So these are the different 128 legs, all the pin descriptions are there. So pin number 5 is the supply, so I'll click on pin number 5, and then I can zoom it here, and then I will see the pin number 5 is connected to the pin number 115, pin number 103, 82, 65, 43. So this pins, this signal is basically, this is a power which is coming from 3 volt and 5 volt section. This power is going to all of this pin. So we can check this 3 volt here. Any of this pin you can check. You can check here. You can check here. You can check this resistor arrays here. You can check anywhere. So here supposed to come a 3 volt. So you can check here a 3 volt. Okay, and if this 3 volt is not coming, then your laptop is not going to turn on. So you go back 3 volt section and just check why 3 volt is not coming. So first, the SIO needs the power. SIO should get this 3 volt. Okay, so you have to check any of this pin. After that, once you got the power, Then the next thing is EC reset and AC in signal and the lead switch. So here we have to check where is my EC reset. In normally SMSC IC don't use the EC reset, so we'll skip that EC reset signal. But there is a one more signal which is very important, that is AC in and the lead switch. So here we'll see where is otherwise you can do on the other way also. You just press Ctrl F and just type LID, okay, then lead CL underscore SIO, then search it, and then you will see this signal is here on the SIO pin number 66, pin number 66. So this is my lead CL underscore SI. So here you should get a 3 volt. This is a lead sensor pin. You should get a 3 volt. If it is a 0 volt, that means the lead sensor is short. So in that case, you have to search the lead sensor. Lead sensor is basically a magnetic sensor. There is a magnet on the screen side, that is on the screen body, and that when that magnet going close to the that sensor, then sensor generate a 0 volt, and if it is away from the sensor, then there will be the 3 volt. So here in normal condition you should get a 3 volt. If here is a 0 volt, then your laptop is not going to turn on. So make sure you should get a 3 volt at this pin. Okay, so this lead switch you can check at pin number 66, or you can check at here also. Okay. So after that lead sensor, then next important signal is called AC in and AC OK. So you can type here, or you can search your AC signal. So we will see your manually first. See your aux OK. Aux OK is a AC OK output. Here also you can check this signal aux OK. You can check here pin number 3. You should get a 3 volt here. Aux OK means AC OK signal. Auxiliary power. Auxiliary power means power coming from the adapters. Okay, so you should get a 3 volt here. So these three signals we will come to the schematic diagram also and check where is this aux. Okay, pin number 3, pin number 2. This pin is going to connect to SIO. Okay, so this is a pin number 3 aux. Okay, okay, so here you have to check a 3 volt. After that aux OK or the AC OK signal, then you have to check the clock pin number 123 and 125. You have to check at pin number 125. You should get a clock that is 32.7 kilohertz, which is coming from the CPU. Okay, this clock is very important. If this clock will not come, then SI is not going to turn on. So you have to check this SUS clock, and if this SUS clock is not coming, then you have to go to the processor and you have to check 32.7 kilohertz crystal, which generate a 32.7 kilohertz. And if you replace the crystal but still SUS clock is not generating, then you have to check the RTC reset and RTC battery. This is clock supposed to generate. Okay, so once this clock generate at pin number 125 SUS clock, then you have to go for the next important signal, that is the power button. See, the power button, there are two power buttons. Basically, one is called the input power button, which user press, and another is called the output power button, which SIO generate, and this that information is going to the CPU. Okay, so there are two power button. One is the input, which user press, and another is the output, which SIO sent to the CPU. Okay, so we'll search where are those power button. Power button normally named the power switch power button, or NBS on, or sometime in on off. Here is a mention the power switch. So this is the power switch. Okay, and where this going signal, you see, you select the signal, power switch in, copy, will come here, click on find, paste this signal over here, and click on the next, and then we'll see that signal is coming on pin number, this pin number 128, 127 and 1 127. Yeah, this yeah, 120, 120. So 128 is a HWAV in, and the power switch is pin number 127. So this 127 is an input signal, which is a user press a power button, and that there you should get a 3 volt, and as soon as we press the power button, and then that 3 volt goes to 0, and when we release that button it come back to 3. So pin number 127. So we'll see on the board viewer 127. So this is a power switch, you can see here. So you can connect a multimeter here, or you can connect the multimeter here also. You should get the same thing. Sometimes it's a very, because this SIO pins are very close, so some user or some technicians are unable to test this signal at pin number 127, and in that case you can check the signal at here also. You'll get a 3 volt here, and once you press that power button, then it should become a 303 variation. And if this variation is not come, then that means your power switch is not working properly. Okay, so you have to check. So once you press this power button, that 303 variation, after that signal there are two output signals supposed to generate, and those signal is called RSMRS3 and post power button. So we'll see where has this post power button. We'll see first in the schematic. So 127, then the power button out. Where are that button? Oh, PSID. This is the RSMRS. You can check this signal also. Pin number 27. This signal is going to the SIO, and press pin number. Sometime this signal, the power button signal, is not same everywhere, so we have to search which is exactly. So yes, I got it, this signal, this signal, this signal, this, you can see. So it is coming from pin number 52, and the signal name is SIO power button, and it's going to page number 10. This is a page number, right? So it's going to page number 10. It's going to the CPU. So we'll search this signal on the board viewer, SIO underscore power button. I'll come here, type find SIO underscore PWR, yeah, button. Okay, got this. Then search. Now you can see this signal is coming from the this SI is going to the CPU. So CPU we can't check the signal, so we'll zoom the SIO, and we'll come here, and it's showing on a pin number 52, right? Pin number 52. This signal name is SIO underscore power button. So here we have to check the signal, and there we'll see first will it when the power up, then that case here voltage will be 0. Once we press the power button, it goes to 3, come back to 0, and again come back to 3. So the 303 variation will generate if the SIO is okay. Okay, so this is a very important signal, and this signal is going to the CPU saying that the power user press the power button. So you have to check this SIO underscore power button signal. 303 variation should be there, and if this signal is not generated, then either SIO is bad or the EC bias is bad. So you have to check that. Okay, so pin number 52, you have to check this SIO underscore power button. Sometimes this signal name is PBTN out, or sometimes say PM power button, or DNB SW power on. So in the different models, the names are different, but the purpose is the same. It's called the post power button. Okay, and after this post power button, you have to check the another signal is called the RSM RST. So simple. You can search your where is the RSM RST, RSM RST, RSM RST, power button we already got, and we'll search RSM RST. Where is the RSM RST? Yeah, this one. You can see pin number 27, PCH RSM RST, and this signal generated by the SIO and sending to the CPU. So I'll click here, and you can see here this on SIO pin number 27, SIO pin number 27. So this is a RSM RST. This signal you can check here also. Here is one resistor. Here also you can check. Here when you press the power button, then in that case here the voltage should be a 3 volt. Before power button, this voltage will be 0 volt. Okay. Once you press the power button, this voltage will become 3 volt. Okay. Such things should be happen. Okay, and if no, then your SIO may be faulty. Okay, after that this two signals going to the CPU, then now CPU has to respond. Okay, so how the CPU respond? CPU will send a two signal that is called SLP underscore S3 and SLP underscore S4. These are the two signals sent by CPU saying turn on all the power plane. But to, to generate this two signal, CPU need something. So see what the CPU need. CPU need first the power, that is called VCC DSW. That VCC DSW is a power to the CPU, and this signal generate 3.3 volt section. See, the 3.3 volt section has the two output. One is called the linear, that is called a VL voltage, and another is called the always, which is a buck converter turn on. And that buck converter voltage is going to the CPU, and the linear voltage is going to the SIO. Okay, so CPU need a power. Then CPU need RTC clocks, RTC reset, and RTC VCC. RTC reset require a 3 volt, RTC VCC 3 volt, RTC reset 3 volt, and RTC clock 32.7 kilowatt crystal. This should be there. Otherwise, CPU is not going to turn on. Another thing, CPU require one more signal is called a VCC DSW. You can check this VCC DSW and or DPW are okay. How to find the signal? Control F, DPW, yeah, this signal, DPWR. Search it. So the DPWR okay signal, we can search here. Here you can see this red line here. Here you can check DPWR okay. Okay, so DPWR okay will be the 3 volt. Otherwise CPU is not going to turn on. Okay, DPWR okay, this signal is going to the CPU saying that your power plane is okay. So you have to check this DPWR okay at this resistor 3 volt. Otherwise CPU is not going to turn on. Deep sleep, DPWR okay means deep sleep wake up signal. Now after the DPWR okay, the CPU got all information, like CPU got the power, CPU got RSM RST, CPU got the power button and RTC section. Then CPU has to respond, and then the CPU send a true signal that is called SLPS3 and SLPS4. And this two signal we can check on the SIO. Now where is my SIO? Here is my SIO. We can search here. Where is SLP3, SLP4? Scroll down, or you can search on a control F button. It's not showing. Where is gone then? Okay. Not sure. We do one thing. We'll find, press control F, then SLP underscore S3 and SLP underscore S4. This first I'll find SLP S4, search, and then SLP S4 signal. So now you can see the SLPS4 signal is showing so many when not on the SIO. So normally in Compil or Quanta motherboard, this SLPS3 and SLPS4 signal going to the SIO, and then SIO is going to turn on. But this is a this is actually Compil motherboard only, but this power sequence is a little different. So the SLPS3 and SLPS4 signal not going directly to the SIO. So now it's showing here also and here also. So we can zoom and we'll see which is a convenient test point for us. So we can test here. So this is a very convenient test point. So here we can check this SLP. So here is a one component. Here is a resistor and here is a diode. So we can check the signal. You can see here. Here is a resistor, so we can check either here, here, or here, anywhere. So you should get a 3 volt here. Okay, and if the signal not respond, then the CPU is bad, or CPU is something problem related to the CPU. Then the next signal we have to check, that is SLPS3. SLPS3, select, search, and then the same thing you have to search like this test point, locate, press it where it is, this component, use it 3, and test this SLPS3 signal, which is generated by the CPU turning on all the power plane. So in this way you have to check the C sections, the how things turn on, how CPU and SIO communicate with each other and generate all the signal. So on these things we check with the help of this diagram also, and with the help of the board viewer also. I hope you understand this concept. Thank you very much for watching this video.